Okay guys, we're going to do the second half of 5-5 today, and we're going to work with the triangle angle bisector theorem. I'm going to skip the proof here just to get you guys the theorem, and this is going to say if a ray bisects an angle of a triangle. So bisect an angle means I cut the angle into two equal angles there. So in that lovely diagram, angle CAD is going to be congruent to angle BAD there. So it's marked in the diagram. What that's going to do, it's going to split opposite sides proportionally. Okay, now here's how they wrote it from the textbook that we used to have. And it says CD over DB equals CA over BA. Now, what I want to show you, this is actually how I like to do the problem. And this is my preference, so I want to show this to you too. And I'll show you the cross products are the same. I would say CA over CD is going to be equal to, excuse me, BA over BD. And you'll notice, or DB, sorry, either way, you'll notice my cross products are still the same. I'm taking CD times BA, and I'm taking CA times, I wrote BD, but it says DB in the other, but that's the same segment. So what I literally do is I look at that angle bisector as a dividing line to create proportions for my two fractions. So let me come over here. I'll show you what I mean on this diagram here. So here's my angle bisector indicated either side of those marked congruent. All I would do here, do 8 over x, those two are on that side of the bisector, equals 2 over 3. The 2 and the 3 are on that side of the bisector. 8 and 2 are in the same position. X and 3 are in the same position. Cross multiply here real quick. Get 24 is equal to 2x. So x would be 12. And then I'm going to go ahead and skip the proof. So just this bottom part, just don't worry about this. Just cross this off. And then we're going to skip on to the next page. All right, so here I'm on the next page. Here's my angle bisector of that triangle's angle. So literally I just make a fraction, just write down on either side of where that angle bisector goes. So I'm going to say 14 over x has got to be in proportion to 8 over 20. We're just going to cross multiply. If I do 20 times 14, I'm going to get 280. And 8 times x is 8x. And we'll just take 280 divided by 8. X there has to be 35. All right, now some of these diagrams are going to get a little trickier. There's my angle bisector, so just go right down the line. So I'm going to do 16.5 over 11. Now, the other side's a little tricky. The P and the 16.5 correspond to each other. Now, it tells you the whole bottom of this is 29. I just need this piece, let me highlight it here, to match up with the 11. So that piece, just take 29 minus 11, and that's going to give you 18. And that's what I want to actually use in my proportion. Then we can just cross multiply 11p. If you do 18 times 16.5, we're going to get 297. I'm going to divide that by 11, and that's actually a nice number. P is going to be 27. All right, and we've got one more here. I just want to show you a little trick to make this one a little bit easier. So I'm going to go right down that bisector. So 7x over 5x is going to be in proportion 10x minus 4 over 6x. Now, you can solve this proportion right as I have laid it out, but I would recommend simplifying this a little bit first. And I can only do this because I have a product on the top, product on the bottom, x here, those cancel each other out. So this would simplify to just be 7/5. You cannot do that over here in this fraction because of the minus sign. Anytime you have a plus or a minus, both of these terms need to get divided by 6x, so we want to just leave that alone. Anytime you have a minus or plus, you don't want to cross variables out. I do want to cross multiply here though. 7 times 6x is going to give you 42x. 5 times this whole quantity, 10x minus 4, so 5 times 10x is going to give you 50x. 5 times that negative 4 would be negative 20. And I'm going to scoot this up a little bit. I like to try to keep my variable positive, but here it's going to be less steps for me to subtract that 50x to the other side of the equation. So I get negative 8x is equal to negative 20. And then we're going to divide by negative 8. And the negatives there are going to cancel out. And x is going to end up being 2.5. Now, a couple more here. These are very tricky. Now, there isn't really an alternative to do here other than what I'm going to show you. And here's my angle bisector. So I want to go right down the angle bisector to create my proportion. Now, to do that here, that's not bad. I have 10 over x. The other side is a problem, though. I don't know what this piece is, and I need that piece to be able to set this up. There's not an alternative way to do this like there is with the side splitter in some cases. So here, the whole side is 15. If I knew the value of x, I could just take 15 minus that value and get a number, but I don't know x. So I have to use an expression here. This piece would be the whole thing, which is 15 minus x. And then I can set up my other side. So the 20 would go over 15 minus x. And we're just going to cross multiply here. So 20x. Now 10 has to get multiplied by both terms, little distributive property. 10 times 15 is 150. 10 times this negative x is negative 10x. I'm going to add 10x. So I'm going to get 30x is equal to 150. And I'm going to divide both sides by 30 there. And x is just going to end up being 5. And then I just had one more practice question similar to that, just because this is a little weird. You don't have a choice here. If you're going to use the triangle angle bisector theorem, you have to go down the sides of the bisector. So here on this side of the bisector, I could just do q over 36. On the other side, though, I need an expression for that piece. And so if the whole thing all across here is 16, this piece would be 16 minus whatever q is. We just don't know what that is. And so once I have that expression, I can complete that proportion. 16 minus q over 28. Then we're just going to cross multiply. So 28q. Now, on the other side, I have to distribute. So 36 times 16 is actually kind of a big number, 576, and then minus 36q. I'm going to add the 36q to the other side here. So take 28, add 36. So we're going to get 64q, 576. And then I'm going to take 576 divided by 64. Q is going to end up being 9. Not bad, but you don't have an alternative. You have to get an expression for that little piece to set up your proportion. All right, and then at the very bottom of the page, this is actually a little bit of a review from yesterday. So I actually have the side splitter theorem because I have 2 parallel lines here. And I also have the triangle angle bisector theorem here. So I'm going to see if I can use both. Okay, now if I wanted to find x here, probably the easiest thing to do would be the triangle angle bisector, right? I could do x over 3, and then this would be kind of weird, but this whole side here would be 2 plus 3, so it would be 5. I just don't know what to put it over. So just for a second there, I'm just going to call that y for 1 second. Okay, now, if you guys remember from yesterday, we did the side splitter theorem. So if I look at those parallel lines, if I go down this side, so the y would go right in here. If I go down that side, and I go down this side, I'm using here the side splitter. All right, so side splitter would tell me 3 over 2, both down that side, would be equal to y over 3, both down that side. All right, I'm just going to cross multiply here. 3 times 3 is going to give me 9. 2 times y gives me 2y. So 9 divided by 2 is 4.5. Now I can just plug that back in, and now I'm using the triangle angle bisector. I know this is 4.5 based on using the side splitter real quick. So I'd have x over 3 is 5. That whole side, 2 plus 3 is 5 over 4.5. So cross multiply here, I'm going to get 4.5 times x. 5 times 3 is 15. And so I'm going to take 15 divided by 4.5. And I'm going to get x is 3.3 repeating. Or if you remember, 0.3 repeating is 3 1/3.